So 5.1 talked about perpendicular bisectors of triangles and circumcenters. In 5.2, we're going to be talking about angle bisectors of triangles. So instead of bisecting the side, we're going to be bisecting the angles. So if a point is on the bisector of an angle, then it is equidistant. We know what that word means now. Equidistant from the two sides of the angles. And we say distance is measured along the perpendicular. We're going to talk about what that means. So just like we had perpendicular bisector theorem, where if a point was on the perpendicular bisector, then it's equidistant from the point, then the endpoint of the segment, endpoint of the segment. So we have this angle bisector, whereas if a point is on the angle bisector, in this case, if ray AD is bisecting it, so measure of angle BAD is congruent to measure of angle CAD. Actually, I should change that to measure of angle DAB. Then we're going to say point D is equidistant from point B and C. So we could word that as saying that the measure of BD, measure of segment BD, is going to be equal to the measure of segment what? CD. So if this point D is on the angle bisector, which it is if angle BAD and DAB and angle CAD are equal, measure equal, the angles are congruent, so that it's bisected by ray AD. So D is on that, so it's going to be congruent to the sides of the angle. The sides of the angle are ray AB and AC. Now it says this is measured along the perpendicular. We have this thing where the shortest distance, or the actual distance as we call it, is the shortest distance from any two point, from the point here to this is going to be where it's perpendicular. That's going to be the shortest where it's perpendicular. It's going to be shorter than if it was anywhere else when it's perpendicular. And we see over here. So we're saying the absolute shortest distance to these sides is going to be the same if it's on the angle bisector. Does that kind of make sense? No, I am sure. Okay, so I think as we go through it, it might make more sense. So
we have to have a converse too.
As I say, we have a converse too. So if, then we're gonna have the converse. So our first was if the point's on the bisector of the angle, so that point D is on the bisector, so it's equidistant from the two sides. We're going to have it flipped around. If a point on the interior of the angle, angle D is on, or point D is on the interior of this angle, BAC, and it's equidistant from the two sides of the angle, so it's equidistant from AB, ray AB, and ray AC, the two sides of the angle are called the sides of the angle, or those two rays that form the angle, then it must lie on the bisector of the angle. And if you want, you can shorten bisector to BIS.
Why did you change it to DAB?
Yeah. Why wouldn't he?
Just extra.
It has to line up.
It could have been BAD.
Well, if you're saying measure of BAD is equal to CAD, you can't.
It's the same angle either way. Just like this, BD is the same as DB. Same thing.
Because it's not the
I just
triangle.
wanted to name it, so we call it a depth. Yeah, it's not like a triangle. So in a triangle, the order matters, but with the angle and the segment, it doesn't. As long as with the angle, the vertex is in the center. So now we have the converse. If the point's on the interior of the angle and it's equidistant from the two sides, so it's equidistant from this side and this side, where it's perpendicular to those sides because that's the shortest distance, then it must lie on the bisector of the angle. So if the measure of segment DC is equal to the measure of segment, measure of angle, let me restart that. If the measure of segment DB is equal to the measure of segment DC, then, unless you must range on Africa, lest we forget, then the measure of angle DAB must be equal to the measure of angle what? CAD, CAD. So we're saying if equidistant from these two sides, it has to be on the angle bisector. So very similar to our perpendicular bisector thing, if the point was equidistant from the two endpoints of the segment, it had to be on the perpendicular bisector. We're saying if the point is equidistant from both of these sides of the angle, it has to be on the bisector of the angle. So pretty similar thing. Instead of perpendicular bisector of a segment, we're dealing with the bisector of an angle. It might not make perfect sense right now, but I think as we work through these, it'll make more sense. Do we have more homework? We will not get more homework handed out today.
Yes.
So, what's the point of going through this?
We're getting a head start for tomorrow.
Because
We've gotten off a little bit, and we were going to get back on Friday on a short day. We didn't have that short
can
day.
we just
So we're progressing
get back
through it,
on
so that way we don't get behind.
we just get back on Wednesday?
No. So, continuing on here. Voice off, please, thank you. We're going to decide whether this information below allows us to conduct, or conclude, excuse me, that point C is on the bisector of angle A. So point C. Is point C equidistant from both sides of the angle?
Yes.
Yes. So according to our angle bisector converse, is point C on the angle bisector? Yes, it must be. There's no other place for it to be than to be on the angle bisector. I confused Mr. Kossel. Nice to meet you.
Anyways,
Anyways,
so you have like that thing has four sides. It has one, two, three.
Okay, well, this or this?
This one too.
Okay, so this doesn't have four sides. What this is it's an angle. The big angle right here. Okay, we have this big angle up here. And then we're saying the distance from this side of the angle. This is what we're calling the side of the angle, the ray that forms the angle. Those two rays are called the sides. So the distance from this side to this point is what's right here. And the distance from this side to this point is what's right here. And we measure the distance where it's perpendicular to the side. So that's why it's showed as perpendicular, because that's the actual distance from the side to the point. Let's hold off on it now. We're going to go ahead and hold off on it now. Okay. So on number 2, point C, it's 2 centimeters from this side of the angle, 4 centimeters from this side of the angle. Is it on the angle bisector? No, because not only can we see that just by looking, assuming this is the angle bisector, which it is, we can also tell because they're not the same distance. They have to be the same distance. So, no, this is yes. On this one, is this equidistant
Yes.
from the two sides?
yes,
But how do we measure the distance?
it says it's already 3 inches.
But how do we measure the distance on these two?
Centimeters.
Where it's perpendicular to the side of the angle. Is this perpendicular to the side of the angle? Ah, no. So even though they show 3 inches and 3 inches, these could be at different angles, and they actually do appear to be at different angles. So because they're not both perpendicular, well, that should have worked out better. And it doesn't lie on this bisector that we see right now. So no. But if it was where this point is, this point D, then yeah, we would have enough information because these are perpendicular, and if we showed these to be congruent, then yes, it would work. But because we don't know that these are perpendicular, even though they're the same number, we don't know they're both perpendicular. They need to be perpendicular distance. Questions on that idea, that concept? Gooch game, split, dope, bank. Yeet. Cash money. Dang. Hollaback. Okay. Ooh, I got a new win. Yes, I got a on that, so that's a fancy win. Hey, so it wasn't back to you. So on example 8, let's find the measure of CD. So we know that angle BAC is bisected, right? Is bisected by ray what? AD or ray DA, right? It's bisected by this ray. And is point D on the angle bisector? Yes. So what do we know about DB and DC? They're gonna be equal distances. So point D is equidistant, the fancy word that obligates, from both of these sides of the angle. And since it's perpendicular distance, that's accurate. So what kind of equation can we do to try and figure out what CD is? Haley. You can set these two expressions equal to each other in our equation. 6x minus 7 is equal to 3x plus 5. We've done equations like this before, right? A time or two. So we solve this one. First math move might be to subtract 3x from each side and then to add 7 so we can get 3x equals 12, correct? And then you can divide by 3 and get x equals 4. Are we done when we find x? Yes and no. No, we have to plug it in. Where do we have to plug it in? One of the equations. Doesn't matter which one. No. Because they're the same measure. But it says find CD. But is this also the measure of CD? Yeah, because they're congruent. Do we have a preference of which one?
3x.
Probably the top one because it's smaller numbers, right, Riley? What she's saying. So we can do 3 times 4 plus 5, get 12 plus 5, and the measure of CD is what? 17.
Yep. Wait. Yep. Just kidding. I thought it was 7. Silly.
Billy Rabbit. Tricks are for kids. Nice.
Yeah, finally.
No one now hates himself for saying the same joke I did. He thought it was funny until I said it. Now it's not. I've hit that level of dad. Let's go. So, where are we going? So anyway, so example 9.
Did you just make a dad joke up?
Right? So,
I'm not even know where to go. I'm just gonna sit back down.
I just gotta sit back down.
The dad joke's
Oh,
always
no.
funny.
So, example 9, find x. Once again, do we have a point that is equidistant from these two sides of the angle? Yes. So the point must lie on the bisector. So what do we know about these angles? They're congruent, equal in measure. Okay. Set up the equation and solve.
Can I do it? Can you tell me that it's
It's right.
Nice. Yep, looks good to me. Oh, good. I just ignore you. You do your favorite.
That's like top 10 favorite memes of all time right there. We know it's on YouTube because we've seen it.
That was really good.
Top 10 people that kill Anna the Devil. Number 10, Shaggy from Scooby-Doo.
Yeah, what's
Yes.
with him being so powerful lately on these memes? And also Sasuke getting choked like crazy.
Number 9, Betty White. Number 8, Queen of England.
Sliced bread's the best thing since Betty White, you know.
I actually made a list.
I went to X
This guy
Island
remembers.
and found one of the angles.
Yeah, like I know like number 1.
Big Chungus.
No, definitely not.
Okay, explain it.
No.
Okay, so these two are angles are equal. I know, crazy. So then you can set these two equations equal to each other and then solve their normal, and it just wants you to find x. So
Questions? Jacob.
No, but can I do number 10?
I had number 10 down.
Did it?
So do I.
what did I just pull out? Oh my god, I just broke something. I'm scared.
I
I
scared.
scared. Not the right time.
Always the right place.
Oh my god.
How does he get caught up on parts?
Yeah.
I'm really
That's
talented.
how we need to
I
do
really
it.
know.
Just stop.
The no look handshake.
I like it. If I
You
can
just so
Alright,
you
we're
see
good.
the highest point.
So, has everyone pretty much done number 10, it sounds like?
Yeah.
Molly has not
Yeah.
gone through yet.
Alright, Jacob, go ahead. You don't need to go.
What?
Jacob's gonna do it on this
Oh,
one
I
though.
did.
Because I'm not in color formation on this board.
I'm not on color formation on the board. You're color formation in general, actually.
No.
Why did you say it?
And it's just extended now, so.
Yeah,
Every time you talk about it.
I just remember number 7 on the list.
Yeah.
It's sarcasm.
Wait.
Oh, yeah.
How long
changes
Don't
literally
talk
every
about
time
it.
he asks about it.
Oh, Jacob, why would you tell him that you're gonna change colors? Like, I would have
That's like-
gone to that board.
that's like
Oh, he didn't
asking
go on
me
color
paint
guide.
dry.
Oh my
Or
God,
is it?
don't tell me.
He would have been like,
Those are
never
some
gonna see
fancy
color.
He would never pull off a crime. He would just say, I'm robbing this bank.
I robbed this thing.
You're
going to jail. Okay, Jacob, explain.
Okay, so it doesn't look like these are equal, but, oh, I got to plug
No.
No, you're just not next.
it in?
No.
Oh, okay,
Jeez,
So
Jacob.
he said it doesn't look like they might be equal, but
they are, because this mark right
yeah, because the angle's bisecting the point lies on the bisector, right?
You just really fancy accents.
Yeah, see that? They're pretty extra. Questions on this
Very
one,
good.
class?
Was that supposed to be a pun?
No.
Oh.
Maybe it was. I didn't realize it was so
I know.
you say.
What'd you say?
Yeah, I have to deal
Pretty
with that.
extra.
You said it in such a weird way, like you knew it.
Okay.
Yeah.
Extra.
That's what you said, extra, extra.
You said it in a weird
Oh,
way.
wow.
Like,
Those are some great ones.
Are we done for today?
Let's just call it.
We're going to, what we're gonna do, class, bring it back down,
Let's not.
take it back now, y'all, okay? So,
This time.
we're going to skip this part for now, but come back to it, and stop crushing it. So, we're going to skip this part, but come back to it, so do not cross it out, do not carry it away. Okay, we're gonna come back to this, but we don't have quite enough time to do it now, so we're gonna do that on Wednesday, and same with the next part. But what we're going to do is construct the angle bisectors, and what we will see is that the three angle bisectors of a triangle are concurrent. What does concurrent mean?
Like, it's
They come back.
current, but it's concurrent. They're
That's
congruent,
how
but
I
also
learned
concussed.
Concurrent
Do something together.
meant that they do something together,
Okay. I just know.
they intersect at the same point. Three or more lines intersect at the same point.
That was my
Concurrent.
second guess.
That was more
Okay.
my fourth guess.
So con, C-O-N, that means together. Like conjoin, join together. Or container, contain, they're together in that container. So concurrent, and current is like the same kind of time, or the same kind of place, or the same spot. So concurrent, together at the same spot, intersect at the same spot. So they are concurrent at a point that we will call the incenter of a triangle. And we'll say how the incenter of a triangle, the incenter can be used to draw a circle inscribed in the triangle. And we'll furthermore say that the incenter can never be outside.
Inscribed. Are these just like made up words or something?
Everything's been made
I
up.
swear.
I
knew you were gonna say that.
Okay, because literally in center, they took the word in and they took the word center and made them
I do that to a lot of
I
times.
literally
Like
been
every
thinking
day?
this whole time,
Every
like,
day.
where I like you say
Aubrey.
concurrent.
Concurrent? Concurrent?
Yeah.
I don't know why.
You're like, do you know what it is? Like I was thinking in my head, like this would be so funny, but like you'd be a bad math teacher if you said it. Like, oh, I don't know.
I don't know what it is either. You know it? Because neither do I.
Dad jokes.
He knows it, but I don't either.
Mr. Foster.
Yeah, he just be like, I don't know, I'm just gonna go Google it.
I just gonna go Google it. I'm gonna go next
In this period, I hated this.
Jacob.
Okay. Hey, so on that note, when's that homework gonna be due, class?
next
Tomorrow,
class.
or Thursday.
Next class.
Tomorrow block.
Hey, you didn't research it.
And it possibly could be tomorrow, Bob, because you might not have school tomorrow.
There's a chance. There's always a chance.
Well,
The chance is higher or lower. I mean, I think we'll have school, but I also don't get paid the big bucks, so.
You know,
you ever talk to Mr. McLean?
I hope we have school because you know what I don't
Maybe.
want to do? Make them days at the end of the year. No, we don't.
Yeah, we don't have like any built in.
That's with community
So
school.
you find Brad.
Because if we say John,